Hello everyone, welcome back. So in this video, we are going to understand Q3, right? Where we have already uploaded the first Q1 and Q2, right? Please go and watch if you have not understood, and if you have also understand the approach that we have used. Okay, so let's understand Q3, right? So the question is saying that minimum jump we have to do to reach the end via prime teleportation. What is this? We'll understand later. But let me explain the problem first with example. Very simple examples will go, and then we'll jump into the code. But don't jump directly into the code, that you will not understand. Okay, and I'll also request you to like the video. Most of you started liking the videos, and I'm really thank you for you. And I'll keep uploading the best videos and premium videos for you. If you support Expert Honda, definitely will get benefited, and I will be your helping partner in your flying preparation. Okay, so let's understand the what we have given the question. So first we should understand the question, and so that let's read the question. The question is saying that you are given an integer array nums, right? And what is the length we have given? N we have given. So you start at index 0, and what is your goal? Your goal is to reach the index n minus 1. Okay, means always you will start, because this is your what array given. Let's suppose call 1 2 4 and 6, and if it represent this array, it will look like what? 0. Means you have to start from here, right? And it is saying your goal is to reach where? N minus 1. Means what is this n minus 1? This is the n minus 1. Means if it is 0 1 2 3, this is your n minus 1. How many elements are there? 4 elements there. Array size is 4, so n minus 1 is what? 3, right? So we have to reach here. I hope you understand. Means jump to reach the end, right? How we are going to do that, we'll understand later. But first understand, we have to traverse the array element, right? And we have to reach to the last element, last index, you can say, n minus 1. So for any index I, you may perform one of the following operations. What are those operations are there? The first operation is adjacent setup, adjacent steps, right? And then prime teleportation. So the jump to index I plus 1 or I minus 1 if the index is within the bound, right? Or the prime teleportation if number at I is a prime number p, you may instantly jump to any index which is not equal to this, and such that this. We'll understand what is this, we'll understand in the deep. Then it is saying return the minimum number of jumps which is required at index n minus 1, we can say, to reach at n minus 1, right? What is prime number? That we'll understand later. Just understand what we have given here first. Okay, so let's suppose we are going with this example, right? Or before that, what the question is saying, that understand. In simple term, what we have given nums, we have given nums is an array, right? So array nums we have given, and we have to start at where? At index 0, that we have seen, right? Then we have to reach to where? At the last index. So our goal is to reach the uh, index n minus 1. Can we say that? With minimum jump, with minimum jump you have to reach the minimum jump, right, which is required to reach n minus 1. I hope you understand the requirement. But what are these operations? We'll understand these operations. So we have two types of moves, right? What are the types of moves we have? So very first we have is adjacent setup, right? Adjacent step. Why I'm saying setup, I don't know. Adjacent steps we have given, right? Means first we have to move what? To I plus 1, or we have to move to what? I minus 1, and this should be within the bound. Can we say that? Within the bound. I hope you understand, right? Very first is to adjacent step where we'll move to I plus 1 or I minus 1, right? Then what we have? Other type of move is prime teleportation. teleportation. Can we say that? These two we have given, right? Very first adjacent, and there is prime teleportation. So if we can say, if nums at what? Nums at I is prime. If nums at I is prime, can we say that? Means what? You can jump instantly to any index, right? What you can do? You can jump to any index instantly, right? How? If j is not equal to I. Just for understanding, if two index is there, means it means we are trying to say, you understand what we have given here, right? You may instantly jump to any index j is not equal to I, such that means nums at j, if we'll do the remainder should become at a 0. Can we say that? So this is the condition we have given. Means nums at j is divisible by this prime number. Can we say that? If this number nums at I, nums at j will be an element of the num, right? Because nums at j is some index will be there, right? But I and j should not be equal to. That is why it is saying j should not be equal to I. When I is or j is not equal to this, so nums at j is divisible, right? By what? By this prime number p. And what is that prime number? If nums at I is prime number and this is your prime number p, if this prime number p means if we'll do the divisibility, it will come 0. I think little messy I have done, so let me clean it. Not like that. So can I say the very first step is adjacent step and the prime teleportation, right? But the nums at I is a prime. If nums at I is prime, right, p, means we can jump to any index if j is not equal to I, where nums at j means nums at j is divisible by the prime number. What is the prime number? P. And what is p? P is nums at I. It's a prime number. So you can say nums at j divisible by nums at I, and it is equal to 0. Can we say that? We can say that this is nothing but what? This nums at I. Then we can say we have to return the minimum number of jumps, right? And that we can get from where? Minimum number of jumps we can get from what? It's a kind of what? BFS problem. If you have studied from me, you have know if this type of question will come, obviously this will go to the BFS. So we need a minimum time, minimum number of jumps that will give you the BFS problem. And so if this is based on the BFS problem, we need to find only minimum number of jumps. That's it. And how we are going to do that, we will understand now. But before that, you should understand the concept. What is the key concept is there, right? Very first is prime teleportation, right? So teleportation only works if current number is prime. If the current number is prime, right? If the, you can see right here, if current number is prime, and then we can say destination must have a value which is divisible by this prime number. The destination must have a value which is divisible by this prime number. I hope you understand, right? What is that prime teleportation? It is saying teleportation will work only if the current element, what is at nums at I, this is your current element, and this should be a prime number, and the destination must have a value. Let's suppose the value is v or nums at j. Can we say that? Value, this is value, nums at j is a value element, right? And it should be divisible by what? The prime number p. I hope you understand, right? Let's understand through the example. So let's understand this example we have here, right? So can I take the nums example 1 that we have given, right? What we have given? We have given 1, 2, 4 and 6. We have this. We can take like this. Okay. So index is at 0 means we will start at where? At I, when index is 0. What is the value we have? Is 1. So for the adjacent step, not setup, okay? So adjacent step to index 1, 0, 1, 2, 3. So adjacent step is what? Is at index 1. Can we say that? We will start from here, right? Means this is the start at the index 0, value is 1, right? Adjacent step is index at 1, right? Which is this, right? So at index 1, value is what? Value is, we can say at index 1, value is what? Value is 2. Is it prime number? We can say this is a prime number. Can we say that this is a prime? So teleport, now we have to do what? Teleport to any number which is divisible by 2. Which is divisible by 2, right? What are those numbers? What are those numbers? So 2, 4 is divisible by 2 or not? So indices at what? At 2 is divisible by what? 4. Divisible by 2. The 4 is divisible by 2. Which 2? This prime number. I am talking about this prime number. And 3 is divisible by the prime number. 6 by 3, right? So we can say there is 2 indices. What are those indices? Means we can say teleport to any number. You can create your notes, okay? Which is divisible by 2. What are those indices are there? Indices are 2. What are the indices are there? Indices are there 2. At indices 2 we have 4, and indices 3 we have 6. Can we say that? Right? Now teleport directly to index 3, because these two we have, right? Both are divisible by 2, right? If both are divisible by 2, why don't we directly teleport to here? Sorry, not from here. Give me 1 second. From here to here, correct? Right? Means we will teleport, means don't say teleport, just say jump, or you can say total jump. Total jumps we can do from where? In 2 jumps. From where? 0 to 1 and 1 to 3. And so very first we go here, and from here to we directly go here, right? We can say 0 to 1, 1 to 3. So total jump will get from 1 jump is here, another jump is here. So 1 jump here. So 1 jump here, 1 jump here. So total 1 plus 1 is 2 jumps. I hope you understand. Let's understand the approach. But before understanding the approach, there is a one tricky part. Let me tell you what. So why it is little tricky, and why the question becomes medium, but it's a kind of hard problem, right? So the normal BFS work for adjacent steps, right? If you have understood, right, and if you have gone through my lecture, you have seen that adjacent step only works for what? Normal BFS, right? Right, normal BFS will work for the adjacent steps, right? But here concept comes for the teleportation, right? And right, the prime teleportation, right? So this teleportation depends on what? Prime property of the current value. For example, here 2 we have. So the prime property of the current value and the divisibility. Is it divisible, right? Others values are divisible or not? So if you use a very simple, you can say brute force, right, or native solution, what you will do? You will check every number, right? For what? Divisibility. Can we say that? You will do that? means you will use a simple solution like greedy solution or any native solution. You will check every number for divisibility, and that gives you PLE, right? Because it is slow, right? If it is slow, it is not used for the uh, solution, right? We can have the idea that how does it works. So how you are going to optimize this solution? You have to pre-compute. Understand? Pre-compute. What do you have to pre-compute? The prime factor. You must have heard about this, right? Prime factor. So all the prime factors you have to pre-compute, and you have to store where the indices. You have to store the indices, and that makes your BFS efficient. I hope you understand, right? Don't worry, I will create also another video where I will brief in details. Let me know if you want it, and I can create, right? Write in the comment section that I'll create another uh, set of slides, right? And you will understand in the deep. We'll do the deep dive, right? Let me know in the comment section, then I'll create. Okay. So let's understand further. So what I can say, let's try to understand how the BFS process will work, right? BFS. Okay. Very first, we have given array. What we have given? 1, 2, 4, and 6. Correct. This is our array we have given in example 1, right? So we are starting index at where? At 0, and value what we have is 1, and our goal is what? To reach here at index 3. So here value is 1, here value is 6. Correct. So we will use BFS because we want a minimum jump. Why we want to do the BFS? Because we want the minimum jump. Can we say that? So if we want the minimum jumps, we will use the BFS, right? You remember why we are saying Dijkstra algorithm. Why Dijkstra algorithm works? Minimum distance. We have to find the shortest distance. Understand? So when you require shortest minimum, try to do by BFS. This is the key idea to understand. Whenever you are doing the shortest path algorithm, you are doing the BFS, right? Try to do through the what? BFS approach. I hope you understand, right? So for each BFS level, for each BFS level, right, you will say one jump. Okay. For example, when we do one jump, the adjacent, what is adjacent? For the adjacent, become one jump. Then from here, it will go anywhere. It will become another jump. We will keep at adding all the jumps, and you will say two jumps for this example. I hope you understand, right? So very first, what we should do, if you are aware with the BFS, what we used to do that? Think we used to create a queue. Understand? We used to create what? Queue, if you remember, right? So very first, let's suppose we'll call step. You keep writing into your notebooks or somewhere, right? So you have a step 0, that is called your initial state. Can we say that? If you have a initial state, right, we'll create a queue, and this queue will have 0. Why? Because we are starting at index what? 0. So this is your static index that will store here. Okay. Then we'll create a visited, where you will mark this is visited or not. So we'll store 0 is visited. This is your initial step, right? Then we'll take the steps, adjacent step. For that we'll take steps. Steps is at 0. How many steps we have started? For each step that we have told what? One jump will count. If one jump will do from 1 to 2, right, there will be one jump counted, right? So this we have to also initialize it. Okay. So very first, what you need to do, you will define queue, visited, and step. Okay. Then in step 2, what we should do, we have to start from where? From index 0. What is the value is here? From index 1, what is the value is here? Value is 1. So you can say value is 1 here, right? And then we need to find for the adjacent move. So for the adjacent move, you know what you need to do? You have to move to from 0 to 1, correct? So when you move to index 1, what value you got? 2. Is it valid? Yes, it is valid. Say valid, not invalid, right? Now what you can do? You can do teleportation. I'm talking about the code, right? I'm explaining your code one by one step so you can write the code. I will not go line by line, but I'm trying to show you the steps, right? Then if let's suppose we'll say 1 is not prime. If 1 is not prime, then what we need to do? We'll say, so no teleportation. Teleportation will not happen, right? The very first we'll say adjacent move. Yes, adjacent move. Then we'll do what? Teleportation. 1 is not prime, so we'll say no teleportation, right? So after the steps, this step 1, this is step 0, step 1, let's say step 1. After step 1, what is our queue, right? So this queue will contain, let's call queue is 1 now, right? Then the visited will become what? Is 0 and 1. Then we'll take the steps, and this step will become what? At 1. I hope you understand, right? So after step 1 will become like this. We'll keep doing that until we reach to the last. But step 2 is important. So let's understand the step 2. Now I will cut the video unwanted steps so you will understand. Okay. So in a step 2, now we'll reach to once step 1 is completed, you have this data, right? Now we have in step 2, right? What is the value is there? Value is 2. Okay. Index at 1, our current pointer is at here. So we can say remove the steps from here, right? We can remove this one. Okay. So we have to reach where? At here, at this position. But current position is at here, right? That is 0, 1, 2. This is 1, this is 2, this is 3. So when at step 2, index value is what? Index is 1 and value is 2. So this value is prime, right? This is a prime number. So we'll say yes, this is valid. Understand? Very first, what you will do? Adjacent move you will do. Adjacent move. So adjacent move will do from where? We'll check the this is 2, right? So from we were here, right? From here to here we come. So from index, when we were index at 0, we say already visited. We'll check. That is we are doing the BFS, right? If it is visited, we'll not visit that. Then we'll go with the index 2, and at index 2 we see what is 4. Value is 4, correct? Because we are iterating over the array itself, right? So we'll start from 0, we'll keep moving ahead, right? So index 0 is visited. Index at 2, what we have the value? Value we have 4, right? We'll add into the queue. Just you will do add into the queue. You will add into the queue. Now you will do teleportation, right? So if you'll do the teleportation, what is the prime here? Prime is 2. Can we say that? Now we should jump to any index which is divisible by 2, means just say jump to any what you call index, right, which is divisible by 2. By 2, can we say that? So except 1, because we are at 1. So except 1 we can say right here, except 1. So except 1 we have to move. So what are the things are there? 2 is divisible, and at 3 we have divisible. So index 2 this value having 4, index 3 we have 6. So we'll add both into the queue. But 4 is already added and added on the queue, right? We have just added. See here, we have added already queue. So we'll say index at 2, which is value 4, value is 4, we have already added. So don't do anything, right? Then we'll check index 3, value is what? 6, right? Value is 6. So what we will do here? Add to the queue. Add to the queue. We'll add it. So can I say the now the new queue will become what? After a step 2. So after a step 2, the queue will become what? 2 and 3. Correct? And the visited will become what? 0, 1, 2 and 3. And the step will become what? Is at 2. Right? Now we reach to the last index. So we'll process the next node. So index will become what? Index at 3. This is your last index. Means we have reached to here. And the goal is done. So we'll reach the goal. And so we'll count the what you call jumps. We'll get the 2 jumps answer. Okay. Let's understand the code. So very first, what we need to do, we have given these values, right? Let me increase the zoom. Okay. So very first, what we will do, we'll compute this value, right? The num dot length, you will get the n. You will check if n is equal to 1, means there is only one element, will return 0. There is no need to make a jump, right? Then in step 2, we want to do what? We want to pre-compute the primes, right? Using this sieve to find the prime to up to 10 to the power 6, right? So we have created this function, right? From where you will get the primes. Okay, we'll understand later. Then in the next step, we want to build the prime factor, right? It means what we want to do, we want to map what you call prime factors, you can say prime factors to indices, we can say also. Okay, means we want to map the prime factor to indices. How we are going to do? To do that, you will create the map. Okay, and there will be one integer and there will be list of integers, means the prime factor and the all the indices will store here. Okay, let's understand how. Just you need to create a loop. You will get all the prime factors. How? We'll create a function. This is a what do you call helper function, right? So this helper function will take 2 argument, one element or number, right, and other is a prime or not. If this is prime, we'll return the factors. We'll get the prime factors and we'll add into the prime to indices. So this will be your p, your prime factor, and this we will keep adding all the indices here. The indices start from 0 to n minus 1, right? We'll keep adding there. Now your job start. What is your job start? The BFS, and this is just your template that you understand, right? So this is your queue. This will be your mark the visited, and then we have what? Used prime, right? So used prime will be a set, as you can say, and you can say we used to do what? S steps. So this is your set, you can say. Okay. So will 3 things will define. First of all, we'll add the very first node, we can say. At index 0, we'll add the index 0, then we'll mark it visited, and the steps will start from 0, right? So we'll create the while loop. We'll check until the queue is not empty. We'll keep going, right? First of all, we'll go for all the size. We'll keep calling the values from the queue, and we'll check if it is reached to the last. We'll return the steps, means we have reached to the our goal. Don't do anything. We reached here. Okay. Otherwise, what we will do, we first will go for the adjacent move, right? And then we'll check if it is I minus 1 is greater than 0 and it is not visited, mark it is visited and add into the queue. Similarly, if I plus 1 is less than n, is it visited, not visited, mark it is visited, and then add into the queue. So both we will do. adjacent move, right? I minus 1, I plus 1. This is your adjacent move, right? That you will do. Then do the teleportation you will do, right? The very first you will check, is this a prime number? Yeah, this is prime number. It is, this prime number has been used or not? Yes, it is used. Then don't do anything. If it is not used, okay, let's continue do that. You will check onto the indices, you will get the indices, right? You will mark you will check, is it visited or not visited, add on the visited, right? And add into the queue, and we'll add the number into the use prime. And then all at each time you will keep updating the steps, incrementing the steps, and you will return -1. Okay, apart from that, these are the two methods. Let me know in the comment section. I will uh, create another video where I will discuss these methods, helper methods, right? And I will make you understood. I don't want to make this video bigger, right? And let me know in the comment section. This is very easy functions are there. Let me know in the comment section. I will put in the comment box. Thank you guys, thank you for watching this video, and please subscribe this channel and let me know in the comment section that you like this video or not, right? If you will give us one single like, it will motivate me to create a better videos for you, to make understood, right? If you not understand, I can create another video for you, right? But make sure that you understood what is the requirement here, and you give at least one like from your side. Thank you. I'll see you in the next one.